This section is about taking advantage of the fact that logs and exponentials are opposites of each other to solve equations. So when you're solving an equation, if you have a variable in the exponent, the first thing you want to do is isolate the exponential part. So get rid of everything that's not the exponential. I call this cleaning up the yard. You're trying to get that exponential function all by itself. After that, you log both sides or change the base, and that's how you blow up this particular house. Blowing up the house is my way of talking about doing the opposite operation. So since logs are the opposite of exponentials, we blow up that particular house with logs. Then we bring down the exponent and we solve for x. Once we log both sides, we have the power to bring the exponent out of its high position. And then we solve as usual. All right. So these are two that we can solve without actually blowing up the house with logs. What we can do instead is change our base. So I'm going to clean up the yard on this first one. Whoops. Sorry. I'm going to clean up the yard on this first one, and I'm going to do that by dividing by 18. So I get 1/3 x over 7 equals 2 over 18, which is 1/9. And what I notice is that I can change 1/9 so that it is 1/3 to a power. I can change it so it's 1/3 to the second power. So this becomes 1/3 x over 7 equals 1/3 to the second power. Now, the reason I don't have to use logs here is because my base matches. It's exactly the same base, so I can ignore the base. What I'm really doing when I ignore the base is I'm taking, whoops, that's not a 9. I'm taking the log base 1/3, but we don't have to write that out. What we're really doing is we're just saying, well, they have the same base, so the exponents have to be equal to each other. And then I would multiply by 7, so x is equal to 14. We could check that answer by, so the check for it could be, we'd say, okay, we're going to check it. We'll put x back in. 18 times 1/3 to the 14 divided by 7. Well, 14 divided by 7 is 2, so 18 to the 1/3 squared. That's 18 times 1/9, which is 2. So it checks out. The other type is, well, this is that same type. We're going to divide by 6, so we're cleaning up the yard. And 96 divided by 6 would be 16. And what I know is that I can change a 16 so that it is 4 to a power. So this becomes 4 to the x over 3, and that's the same thing as 4 squared. Now I can ignore the base because they're the same, and I can just look at my exponents and say, well, x over 3 has to equal 2. Now I can multiply by 3, so I get x equals 6. If I check that one, I get 6 times 4. 6 divided by 3 is 2. So I have 6 times 16, and if I check that, that is 96. So it checks out. All right. If I don't have a common base, and I can't make a common base easily, then I use the most useful log property of all, which is I log both sides, and then I can bring my exponent down in front. So that's a really powerful log property, and I'm going to log, and I'm going to just use one of the logs that's on my calculator, like a common log. I'm allowed to do this because the basic property of algebra says that if I do something to one side of the equation and I do the same thing to the other side of the equation, I still have an equation. Now I'm going to use the log property that says I can bring that x down in front. So I have x times log of 1.09 equals log of 4.7. And then I can solve for x by grabbing x equals log of 4.7 divided by log of 1.09. I'm going to grab a calculator to do that. So I pull up my calculator and I do log of 4.7. I close my parentheses, divided by log of 1.09. Oops. Close my parentheses, I hit enter, and I get 17.957. I'm just going to show you something. You can store this number on your calculator by hitting the stow button. Now that big ugly decimal is going to be stored as whatever letter I type next. Using the alpha button, I can get to the letters, and so I'm just going to save it as A. Now that decimal is on my calculator as an A. So I don't ever have to type it or round it. And the reason I'm doing that is so that you can see that I can still check my answer. I'm going to do 1.09 to the A power and see if I get 4.7. So again, we solved it. We got x equals 17.957. That's a good answer, but I want to check it, and I want to check it with the exact answer. So that's why I'm storing it, so that I can use that actual answer. So I do 1.09 to the, and then I type in an A, and I hit enter, and it's exactly 4.7. That's kind of satisfying. The other useful log property, so we're going to solve this one. We're going to clean up the yard. So we're going to subtract, and we get 2e to the negative x. 74 minus 37 would be 43. No, it wouldn't. I lied. It would be 37. And then we divide by 2, so we have e to the negative x equals 37 divided by 2. Now, instead of just using any old log, this time it makes the most sense for me to do the opposite of e. So I'm going to do natural log of both sides, because I don't even need my calculator to figure out what natural log of e is. And then this becomes negative x because the natural log and the e to the power cancel out. So I'm going to be doing natural log of 37 over 2, and then I'm going to divide by negative 1 to make the sign correct, or just change the sign after I type it on my calculator. And I get a positive 2.918, but I'm going to use negative 2.918. Again, if I wanted to check it, I could store that. I hit stow, alpha, and my favorite letter. And then I'm going to do the same equation, but with that stored value. So it's going to be 37 plus 2 e to the negative a. And I should get 74 when that happens. Oops. I didn't change the sign when I stored it. So if I actually need to, I am changing the sign twice at this point because I didn't save it as the negative version. I saved it as the positive version. So it would become positive again when we change the sign. So that does work. Since A is negative 2.918 and I used positive 2.98, it's good. All right. The next type of equations are equations that have logs in them. You might have log on just one side of the variable, you might have logs on both sides, and you might just have multiple logs. I'll show you how to do these ones. So if I have log on one side of the equation, I'm going to do the opposite of a log. The opposite of the log is an exponent. So same base, I'm going to do log 4 to the log 4 of 4x minus 3. I'm allowed to do that if I also do it to the other side of the equation. On this side, the logs and the exponential cancel out, so I have 4x minus 3. And on this side, I have 16 times 4, which is 64. I'm going to add 3 and divide by 4. I'm not going to panic that I get a fraction, and I'm just going to leave it like that. All right. This one, I have a lot of yard that needs to be cleaned up, so I'm going to subtract 8. And I'm going to divide by 6. And then I have to undo a natural log, so this time I'm going to raise e to the power. On this side, the exponential and the log cancel out, so I get x minus 6 equals e to the 1/6 power. I can add 6, and I get 6 plus e to the 1/6 power. If I wanted that as a decimal, I could certainly grab it on my calculator. I'm happy with that as an answer because e is a number kind of like pi. So you know how sometimes your teacher's okay with you saying the answer is 3 pi? I am okay with you having an answer with an e in it. I should check for extraneous answers, and what I mean by that is, will my answer actually work in the log? It won't work in the log if I get a 0. This value has to be greater than 0. So I want to make sure that I don't get a 0 or a negative answer when I plug it into the log. If I put 67/4 times 4 minus 3, I get 67 minus 3, which is 64, and that is totally okay to put in a log. While I'm here, I might as well double check. Is it true that 4 to the 3rd power is 64? Yes, it is. So that's good. Here, I have 6 natural log of 6 plus e to the 1/6 minus 6 plus 8. And I get 6 natural log of e to the 1/6, which is bigger than 0. So it's not extraneous, but we're just checking our answer. Natural log and e break down, so I have 6 times 1/6 plus 8. And is it true that 1 plus 8 is 9? For sure. And so that's a good check. Checking for extraneous solutions means you're going to look to see if your answer works in a log, and you're also just going to check to see if it works. I'm going to make a second video for the other type of log problem, so this particular lesson has 2 videos.